Okay, we're going to talk about the relationship between mass and moles in a balanced reaction. Last unit we worked on balancing and writing reactions. So I've written an example reaction where hydrogen plus oxygen yields water. In a balanced reaction, you need 2 moles or 2 molecules of hydrogen, 1 molecule of oxygen, and 2 molecules of water. Now, in order to find out how much each of those molecules weigh, we add up the molar mass of each molecule from the periodic table. So for hydrogen, that mass is 2.0. For oxygen, it would be 32.00 grams per mole. And for water, it would be 18.016 grams per mole. Now, this is why we don't use grams when we're balancing equations, because everything has a different mass, okay? The way that I can relate this to you is by talking about sandwiches. So I hope you're not hungry, but here is a sandwich equation, okay? Let's say that every sandwich has 2 slices of bread, 3 pieces of lunch meat, and 1 slice of cheese. Well, the mass of the bread is not the same as the mass of the cheese, but we measure both of them in slices, okay? So imagine that a mole is like a slice, okay? And because we're talking about a slice of hydrogen and a slice of oxygen, they're going to have different masses. But for every sandwich, 2 slices of bread plus 3 pieces of meat plus 1 slice of cheese equals 1 sandwich. Now, the mass of the sandwich is going to be the mass of the bread plus the mass of the meat plus the mass of the cheese, which is just conservation of mass. That was Lab 5A. So we've already studied conservation of mass. Now what we're going to do is look at the mass to mole relationship in all of this. So what does that mean? That means, let's say I put in 6 grams of hydrogen. If I have 6 grams of hydrogen that I expose to unlimited oxygen, how many grams of water should I get out? Okay, well, 6 grams of hydrogen divided by 2.016 grams per mole is about 3 moles of hydrogen. Okay? Well, what is the relationship between moles of hydrogen and moles of water? Well, for every 2 moles of hydrogen that I put in, I get out 2 moles of water. Set up a ratio. If I've got 6 grams of hydrogen, then I'm putting in 3 moles of hydrogen. Whoops, just hydrogen. How many should I get out of water? Well, you can cross multiply and get 6 equals 2x. Divide by 2, and you should get that you should have 3 moles of water if you start out with 3 moles of hydrogen. Well, why is this important? Because on your lab, you're going to be looking at the relationship between iron and copper. If I put in this much iron, how much copper should I get out? The equation has a 1-to-1 mole ratio between iron and copper because I'm looking at the prefixes, or the coefficients in front of iron and copper. So there's a 1-to-1 mole ratio. So let's pretend that I put in 56 grams of iron. Iron has a molar mass of 55.85 grams per mole. Copper has a molar mass of 63.55 grams per mole. So if I react iron if I react 56 grams of iron, then I am essentially reacting 1 mole of iron. Okay? And if I put in 1 mole of iron, I should get out 1 mole of copper, right? Because there's a 1-to-1 mole ratio. So I put in 1 mole of iron, I should get out 1 mole of copper. Getting out 1 mole of copper means that I would get out 63.55 grams of copper, because that's how much 1 mole of copper weighs. Okay? Now, let me show you what would happen. If I react 1 mole of iron, then I'm reacting 1 mole of everything. So let's just show you that the mass is the same on both sides. Okay? If I react 1 mole of iron, then I'm reacting 1 mole of everything. 1 mole of iron is 55.85 grams. Copper is 63.55 grams. And chlorine, two of them. So what goes in is 190.3 grams, and what comes out is 190.3 grams. Now, you proved this in the Lab 5A that mass is always conserved even if it changes form. So that's what we're looking at in this lab is, okay, well, if I put in 56 grams of iron, then based on the equation, they're a 1-to-1 mole ratio, which doesn't mean that I'm going to get out 55 or 56 grams of copper. It means that I'm going to get out 1 mole of copper, and 1 mole of copper has the mass of 63.55 grams. So that is the goal of the lab, and you will be able to see this and measure it on Wednesday.